is approximately f of a plus f prime of a x minus a. So basically I'm using 4 for a, right? So I need to find f prime of 4. I'm also going to need to find f of 4, which thankfully they gave us that. So f prime of 4, go to 4, 1, 2, 3, 4. Find f prime. 1, 2, 3, 4, 5, 6. So f prime of 4 is 6. F of 4 is negative 2. Well, fantastic. They already gave me everything I need to know. So let's write the equation here. The equation of the regular line would be y minus y1 equals n times x minus x1, right? If you want to jump straight to here now, you can. F of a. F of a is f of 4, which is 6, plus, excuse me. Goodness, I really wish I had someone here to double check what I say. F prime of 4 is negative 2, I'm sorry. Negative 2 plus f prime of a, there we go, which is 6, times your x minus a. Now the x value here is 3.9 minus your a value, right? So this is f of 3.9. Now we could grab that, go ahead and multiply it through, calculate it out. This ends up being 6 times a negative 0.1. Okay, so that's 0.6. And then negative 2 minus 0.6, negative 2.6. So again, this is approximately. Now let's explain something here. It says, is your estimate too high or too low? Will this be too high on the graph, or will negative 2.6 be too low of a value? Well, first, f prime of x, let's do a little sign analysis here. At negative 1 and at, what is that, like 6.5? So it's negative, positive, negative. So it's decreasing, increasing, decreasing, right? So if I drew a little picture here, negative 1, 6.5, and then it's got a 0 roughly at, what is this, 2.5? You got a 0 roughly at 2.5. So it's going to have a level point, or it's going to actually come through and hit 0 at 2.5. Let's forget that for right now. That really doesn't change anything. It's negative, positive, negative. No, I'm sorry, your zeros are here. See, I just made the same mistake that most of my students would. I started looking at this thing as f. I'm glad I saw that that was f prime. Okay, so negative, positive, negative, so it's going to be decreasing, increasing, decreasing, right? So it doesn't really matter exactly where this is at. It's just decreasing, increasing, decreasing, right? And this is for okay, so that's 4, and is 3. We're trying to find 3.9, right? We are trying to find 3.9. So here's the point we're trying to find. Here's the point that we're using. So is the point we're using high or lower than 3.9? Well, because this thing is increasing right here, 4 is higher than 3.9. So I want you to write this. Your approximation is too high, right? So let me write it this way. Approximation is too high because f of x is increasing at 4. It's increasing at 4. In other words, the tangent line is above x, right? Tangent line is above f of x, right? Okay, so again, what I'm doing here is I'm plugging a point into a line that I associate with the graph. It's very close to it. It's not exact, but it's very close. Okay, and there's one thing that I would like you to do here before we go on. Down at the bottom, I'm going to give you a little vocabulary word, a normal line. Normal lines are perpendicular, and I just misspelled perpendicular, that's an E right there, are perpendicular to a tangent line. At a given point. A normal line, if you had a tangent line, for example, this guy right here, let's say we got a curve, a normal line, here's your tangent at this point. A normal line is going to be perpendicular. We just call it a normal line. So I want you to write this down here. For perpendicular, because we always forget this for some reason, slopes are opposite. That's talking about positive versus negative reciprocals. Opposite reciprocals. All right? We'll explain a little bit more when we get into class, and that's all we have for today.